Welcome to homework.
31.32. So we have an inductor hooked up to an AC generator that produces this EMF across it. First, we'd like to find what is the maximum current through the inductor. We want to find what the EMF is when the current through it is equal to that maximum current. And then what's the current when the EMF is negative 12.5 volts and increasing in magnitude, which means that it's actually becoming more negative. So starting at A, the amplitude of the current is going to be the amplitude of the EMF divided by the reactance of our inductor. The reactance of an inductor is omega L. So omega D L. And so this is 5.22 milliamps. Now for part B, when the current is at a maximum, its derivative is 0. And we know that there's a pi/2 phase difference between the EMF and the current, which means that, the one is the derivative of the other, basically. And so when the maximum current is going through the inductor, the EMF will be 0, because the current is sine of omega d t minus pi/2, and that's a cosine. So when the cosine is 0, when the cosine has its maximum, the sine is at 0. So that's the answer for that part. And so now we have this. It's E sub m sine omega d t. And now we want this to be equal to negative 1/2 E sub m, which just means that we want the sine of omega t to be negative 1/2. But we also want its magnitude to be increasing, which means it should be more negative. So if we differentiate this, we'll get an omega d cosine omega dt and we need this to be negative as well. This is at a particular point in time, and this is, in order for it to be the derivative, is at all points in time. So we need a t that satisfies both that the sine is negative 1/2 and that its derivative is negative. And so what these imply is that omega t has to be 2 pi n minus 5 pi/6. It's a little bit awkward, but you can figure this out from thinking about the values of sine and cosine going around the unit circle or whatever. And then the 2 pi n just means that this happens every 2 pi radians a phase because it's periodic. And so going back to here, I think this is 31-29 in the book. We have that the current is going to be its amplitude is the sine of 2 pi n minus 5 pi over 6 minus pi over 2 and so then this works out to be 5.22 milliamps, or I sub m, times the square root of 3 over 2, and so this is 4.51 milliamps.